Yes, good afternoon, dear students. Yes, so in the last class, we were discussing about the electrolytic cells and electrolysis, right? So we have seen the definition, okay, and what all happens in electrolytic cell. So these all things we have discussed in our previous class, right? So we were discussing some of the examples, okay, of the different cells, that is electrolytic cell. So in electrolytic cell, what happens? So you have two electrodes in the same electrolyte solution, okay, and in the same cell, oxidation and reduction takes place. So here the anode and cathode, two electrodes are there, and these are oppositely charged, okay, as compared to that of electrochemical cell. So your anode here is a positive and cathode is a negative, okay. So anode, it undergoes oxidation, and cathode, it undergoes reduction, okay. So what happens when electrolysis, when you put an external electric voltage? So in electrolytic cell, what happens? An external voltage is applied. So when you external voltage. So whatever the cations are there, so that will be liberated at cathode, okay, which is negatively like charges will attract each other, right? So what happens? The cations which are liberated, that are okay, so they move towards the cathode, which is negatively charged, and the anions, which is negatively charged, okay. Okay, so these anions, so these anions that is negatively charged, so these will move towards the anode, which is positively charged. Okay. So this is the electrolytic reactions which takes place. Okay. So now this also we have discussed. So when you have two or more ions, okay, when you have two or more ions, what will happen that time? So that time the ion with the higher reduction potential. Okay, we have seen the electrochemical series also. So according to chemical series. Okay, so the values are given of different metals. So the ion will at cathode, and while the ion, which is of lower reduction potential, so that will get what liberated at anode. Okay, so these are the basic things which occurs in your electrolytic cell. So in the last class we had discussed about the electrolysis of molten NaCl using graphite electrodes. Okay, so your two electrodes are there, which is of graphite, that is, which is made up of graphite is nothing but it is allotrope of carbon. Okay, so the two electrodes which are made up of the carbon electrode, that is a graphite electrode, so that is dipped in what? It is dipped in the molten molten solution of NaCl, that is your sodium chloride. Okay, now what happens? Sodium chloride solution is there in the beaker. Okay, two electrodes are dipped. So when you put the external source, okay, what will happen? Reaction takes place. So at cathode, reduction happens. That is at the negative electrode. What happens at reduction? Reduction is nothing but gain of electrons. So you can see by the reaction. So one electron is gain and you get Na. Right. And at anode, what happens? Oxidation takes place, which is a positive electrode. So what happens? Cl minus gives you half Cl2 gaseous plus one electrode. Okay, so your one electron is lost. So what happens here? Whatever the cathode, one electron is gained. Okay, so that is gained from this anode, right? So the electron which is lost over here, so that is taken in the reduction reaction, right? So what is the overall reaction? So the electrons, okay, you can see 2 NaCl. So you have to add up this cathode and anode reaction, you get the overall cell reaction. So overall cell reaction, it is occurred by the electrolysis. So 2 NaCl, okay, it gives you 2 Na and plus Cl2 anode. Okay, so this is the reaction. Okay. So next is electrolysis of aqueous NaCl solution. So that was molten. So here we are taking the NaCl in a aqueous. Aqueous means what? Aqueous means in water. Okay. So we are going to add NaCl solution. That is, we are going to take NaCl in water. Okay. So you get what? Aqueous NaCl solution using the graphite electrodes. Okay. So what will happen here? So as we take NaCl solution, when we add in water, okay, you are going to dissociate. Okay, in the previous step, what we have taken? We have taken a molten NaCl. Can you hear it now? Okay. See here, so in the previous electrolysis method, okay, so there what you have a molten NaCl. What do you mean by molten? Molten means it is in the what you can say a solidified way. Okay, so in that, what you're going to do, you're going to take the NaCl and you're going to heat it. So after heating, it will be converted into the aqueous solution. Okay, but here what we are doing here directly, we are taking a NaCl and we are taking the aqueous NaCl, means what, it is dissolved in water. And when you add this NaCl in water, okay, what will happen, it will dissociate. We know how it dissociates. It dissociates into Na plus ions and Cl minus ions. Okay, and water is also present, so these water molecules also get dissociate into H plus and OH minus ions. Okay, so this is the dissociation of these salts. Okay, so NaCl gets dissociate into Na plus and Cl minus, and water will get dissociate as H plus and OH minus ions. So again, when you put the external source, what will happen? The reactions will takes place. Okay, at cathode and at anode reaction takes place. So at cathode reduction takes place. Okay, so H plus plus one electron gives you half H2, and at anode what happens, oxidation takes place. So here there is a what loss of electrons. Okay, so that electron which is lost here is taken by at cathode. Okay, so we know that the standard, so we know that whenever you have ions, okay, so we have to calculate its standard reduction potential. We consider what, we consider the standard reduction potentials. So here we know the standard electrode potential of hydrogen is 0 volts, and that of Na is what, it is minus 2.71 volts. Okay, so this is greater, so minus values come below and positive values comes above, right, when we see the electrochemical cell. So standard electrode potential of H plus, okay, so this is more as compared to your sodium metal. Then when we compare your standard reduction potential of chlorine, so it is 1.36 volt, okay, which is less than that of water. Okay, so water and HO2, that is of oxygen, it is 1.23. Okay, so this is less. So O2 should be liberated at anode. So whenever you have more than two ions, so that time we are considering the reduction potential values of those. Okay, so what will happen? O2 should be liberated at anode. Okay, and but a dissociation of H2O into O2, it is kinetically slow. So what is done to enhance the rate of the reaction? We are putting an external potential is applied. Okay. So what will happen? The Na plus and OH minus ions which are liberated, so that will form what? It forms a NaOH. Okay. So it forms NaOH, and what will happen to the pH of the solution? pH of the solution will increase, because in the same solution, okay, in the same solution, what is there? In the same solution, when we consider the same solution, so in the same solution, so if I consider a beaker, okay, if I consider a beaker here, just a second. Okay, if I consider a beaker and I have the two electrodes, okay, and what I am having, NaCl. So when I add in water, so Na plus ions and Cl minus ion get split, and water will split into H plus and OH minus ions. Okay. So when the external electric current is this, so what is formed? So one here at the one position. Okay, what you will get here? You will get NaOH. Okay, NaOH. And so Na will combine with this OH to form you NaOH. So what will happen? Preferentially, the pH of the solution will increase, okay, after electrolysis. So what is the overall reaction? So there is a presence of water. So some of the H plus ions, they will get combined with OH and they form water, and there will be NaCl. So when this NaCl combines with water, okay, it will give you what? Na plus and OH minus ion plus half H2 and half Cl2 at anode. Okay. So these are the electrolysis of an aqueous NaCl solution. So this is the difference, okay, between the molten and the aqueous. Okay. So next is electrolysis of molten PbBr2 using platinum electrodes. Okay, so again we are going to take lead bromide, okay, and that we are going to heat. So what we are going to get? We are going to get Pb plus 2 Br minus. Okay, so what happens at cathode? Reduction takes place. Okay, so this Pb, that is lead, it will take 2 electrons and it will form Pb. So it is 2E minus, gives you Pb solid. Okay, so this is aqueous. And at anode, what happens? Oxidation takes place. So 2 Br minus aqueous, giving you Br2. Okay, and 2 electrons. Okay, so after overall reaction, PbBr2. Okay, and so 2 electrons. So it will be Pb at cathode and Br2 at anode. So this is a overall reaction. Okay, so what is done? So we are going to take, so in that we have a Pb, that is lead bromide as a solution, and we have what? Two platinum electrodes, okay, which are connected externally. So like this, okay. So after the electric current has passed, so these are the reactions which takes place respectively at cathode and anode. Next is the electrolysis of acidified water with platinum electrodes. Okay, what do you mean by acidified water? Okay, means what? In the beaker, I'm going to take water. Okay, I'm going to take water, and to this I'm going to add acid. Okay, so I'm going to add a few drops of H2SO4. So when H2SO4 is added, so what concentration is increased? The H plus ions concentration is increased, right? So what will happen to the solution? It becomes a acidified solution, right? So as it is a neutral solution, because water is there, water is a neutral solution, right? So when to that, when you add H2SO4, what will happen? The concentration of the H plus ions, what will happen? It will increase. Okay, concentration of H plus ions will increase and it becomes a acidified solution. So now what will happen? Whatever the water molecule is there, that will get dissociated into H plus and OH minus ions. Okay, it will get dissociated into H plus and OH minus ions. So what are the overall reactions? So at cathode, okay, so what are the overall reactions? So at cathode, so H plus 1 electron gives you half H2. Okay, half H2 gas. And at anode, that is oxidation, OH minus gives you OH plus 1 electron. Okay, or add 4 OH minus, 4 OH minus giving you 2 water plus O2 gas. So the overall reaction becomes H2O. Okay, after undergoing electrolysis, it will split into 2H2 at cathode and O2 gas at the oxygen is liberated at anode. Okay, so this is another example of electrolysis. So these are different electrolytic cells. So the last one, okay, you have one more. So electrolysis of H2SO4 using platinum electrode. So these are not there for your exam point of view, just we are seeing. Okay, so when H2SO4 is there, it will split into 2H plus and SO4 minus 2. So just see the cathode reaction, see the anode reaction, okay, and okay, so these are the overall reactions. Okay, fine. Next is electrolysis of copper sulfate solution using platinum electrodes. So copper sulfate solution, so it will split into copper plus 2 and SO4 minus. So see the cathode reaction and anode. So just you have to know that at cathode reduction takes place in electrolytic cell and at anode oxidation takes place. Okay. So just see the reducing potential values and then write the overall reaction. Okay. Then next is electrolysis of copper sulfate solution using copper electrodes. Okay. So what is happening here again? So these are the reactions which are taking place. Okay. So here we are using platinum electrodes and here we are using what? Copper electrode itself. So your copper solid electrodes are dipped in what? It is dipped into the copper sulfate solution. Okay. So these are the overall reaction. So here what we are doing, one will be a impure copper, another will be a pure copper. So from the impure copper, when you put electrolysis, okay, by this method, So what will happen? Whatever the pure copper is there, so that will get melted from the impure and it will go and settle on the pure this. Okay, and whatever impure is there, that will go and reside in the at one electrode. Okay, in that impure section. So like this. So this is the application. Okay, so by this, by using the electrolysis of copper sulfate using the copper electrodes, you can purify your impure copper electrodes. Okay. So next is the Faraday's law of electrolysis. So very important. So in the last class, we had discussed about what? We had discussed about the Kohlrausch law, right? We have discussed about the Kohlrausch's law. So that is very important. So let us see Faraday's law of electrolysis. So this Faraday's law of electrolysis, okay. So it is a quantitative aspects. Okay, it is a quantitative way of determining the electrolysis process. Okay, so these are given in two laws. So first is the Faraday's first law of electrolysis, and second is the second law of electrolysis. That is Faraday's second law of electrolysis. So important. Okay, mark this as important. So the amount of chemical substance which occurs at any electrode during electrolysis by a current is directly proportional to the quantity of electricity passed through electrolyte. So whether the electrolyte is molten or solution form. Okay. So what happens during electrolysis? So when this electrolysis process takes place, when an external electric current is passed. Okay. So when when externally your electric current is passed, so what happens? The amount of substance start to get what? Deposited, or it gets liberated, or it gets what? To liberate, right? What will happen? It will start to liberate at any electrode. So at the moment you start electrolysis, what will happen? At cathode and anode reaction start. So whatever the substance has to be deposited or liberated, it will get, okay, at any electrode is what? It depends on what? It depends upon the quantity of electricity, what is you are supplying. Okay, quantity of electricity passed. So how much electricity you are passing, so that much amount of substance will get deposited, okay, or it will get liberated at the electrode. So how much amount of quantity of electricity you are passing through the electrolytic solution, so that much amount of the substance, that is amount of substance, starts to deposit or liberate at any electrode. Okay, so this is your Faraday's first law. So the amount of substance which gets deposited or liberated at any electrode is directly proportional to how much amount of current you are passing through the electrolytic solution, whether the electrolytic solution is molten or it is in aqueous form. Okay, so how it is mathematically given? Okay, so W is what? It is the weight of the this what? It is a weight. Okay, that is weight is considered as in gram. So that is a gram of substance which is deposited on passing. It is directly proportional to Q. What is Q? Q is the coulomb of electricity, right? How do we calculate electricity? Electricity, it is calculated by Q. Okay, that is coulomb. So what is electrolysis? So the amount of substance which it deposited or liberated at any electrode is directly proportional to what? It is directly proportional to the quantity of electricity which is passed through the electrolytic solution. So W represents your the gram of substance. How much gram of substance is liberated? Okay, is directly proportional to Q. Q is nothing but the coulomb. Okay, so that is coulomb of electricity. So that is, okay, that is W is equals to, is directly proportional to I into T. Means how much amount of in how many seconds. So that is Q can be coulomb is nothing but, okay, Q is in coulomb. So your coulomb can also be expressed as I into T. That is how much ampere is passed in how much time. So if you remove the proportionality sign, then W is equals to Z into IT. Okay, Z into IT, where I is what? Your Z is what? Z is a electrochemical equivalence. Okay, it is called as the electrochemical equivalence. So we are removing the proportionality sign and we are introducing the Z, constant Z, which is called as the electrochemical equivalent. Okay. So suppose if here it is given, see, suppose, okay, if I is equals to, that is the amount of current which is passed in is 1 second, okay, is 1 second, then Q is what? If you substitute, so Q, and therefore Q will be what? That is Q will be 1 coulomb. Okay, then what will be your, how much gram of this is substituted? So W is equals to Z. Okay, what it is? So W will be equal to Z. Okay, so this is your chemical equivalent. So electrochemical equivalent of a substance is defined as what? The mass of the substance which is deposited. Okay, the mass of the substance which is deposited when a current of 1 ampere is passed through 1 second. So that is your equivalent, chemical equivalent. So how, what is the definition of chemical equivalent? Yes, so the mass of substance, okay, the amount, that is a mass of substance, W, okay, it is uh, defined as what? The mass of the substance deposited when current of 1 ampere. What is Z? Z is nothing but I 1 second. Okay, electrochemical equivalent. Is it clear? So if you want to find the charge of 1 mole of electron. Okay, now how do you calculate the 1 mole of electron? Charge of 1 mole of electron is nothing but 1 Faraday, right? 1 Faraday is nothing but 96,500. So it is given as what? It is given as Avogadro's number into 1.6 to 10 raised to minus 19 coulomb. So charge of the electron. So if you want to calculate the charge of electron is given as what? Na, that is Avogadro's number, because you are finding 1 mole. 1 mole is nothing but Avogadro's number. Okay, 1 mole is nothing but it contains Avogadro's number of electron. So Avogadro's number into the electron charge is 1.602 into 10 raised to minus 19 coulombs. Okay, so what is 1 Faraday? Yes, what is 1 Faraday then? So if you calculate this, okay, so 1 Na into this, so it is 6.022 into 10 raised to 23 into 1.60201 into 10 raised to minus 19 coulomb. So after you get what is this? It is nothing but 96,487 coulomb per mole. Right. So this is equal to your Faraday, that is 96,500 coulomb per mole. Okay. So the quantity, so 1 Faraday, what is the value of 1 Faraday? It is 96,500 coulomb per mole. Okay. So this is the value. So this is the value of 1 mole. So Al plus 3 electrons. Okay. It gives you Al. So Al plus 3 is nothing but it is the amount of substance. So it is amount of substance is 1 mole. 3 electrons means how many current is passed? It is a 3 Faraday, because charge of 1 mole of electron is 1 Faraday. So 3 moles of electron is 3 Faraday. So giving you 1 mole. So 1 mole of Al, what is the equivalent weight of Al? It is 27 grams. So therefore 3F will be equal to, so we know that to 96,500. Okay. So charge is required to form 1 mole of 27 grams of Al. So one charge is nothing but 27 divided by 3 into 96,500. Okay. So like this, you are going to get the value, okay, to calculate the Faraday. Okay. So based on this also, there are problems. Okay. So that what we will do after completing the chapter, we will do the problems. Okay. Yes, so these are the problems. So that let us do at the end of the session. Okay. So next is what? Second law of electrolysis. Is it clear? The first law of electrolysis is clear. Any doubts up to here? Okay, fine. So let us go for the second law of thermodynamics, electrolysis. Okay. So here, so what does the second law of electrolysis, Faraday's second law of electrolysis states? Okay. So it states that when same quantity of electricity is passed through different electrolytes. So in the last first law of electrolysis, what we saw, okay, so how the amount of substance deposited or liberated at any electrode is directly proportional to how much amount of electricity you are passing to the electrolytic solution. Okay, so it is directly proportional to the Q, right? So from that we got W is equals to Z into IT. So this was the equation which we got. Now in second law of electrolysis, so what they have said that how much quantity of electricity, okay, you are taking, okay, that is the same quantity of electricity whatever you are taking, so it is passed through different electrolytic solution. Okay, so here you have to consider different electrolytic solutions. Suppose you are having A and B, okay, two different electrolytic solution. So how much ever the same quantity, so we are taking same quantity of electricity, so same quantity of electricity, it is passed to what, it is passed through the different electrolytic solutions. So different electrolytic solutions are there. So whatever the amount of substance is produced, so the amount of substance obviously, right? So when you are passing the some quantity of electricity in the electrolytic solution, so some amount of substance will be produced at the electrolyte. So this, whatever the substance of, whatever the amount of substance is produced at the electrodes is what, it is directly proportional to their equivalent weight. Okay, it is directly proportional to their equivalent weight. So this is the second law of electrolysis. So the same quantity of electricity which is passed to the different electrolytes. Okay, so the whatever the amount of substance is deposited or liberated at the electrode is directly proportional to, okay, is directly proportional to their equivalent weight. Okay, so this is the second law of electrolysis. Now here also same, Q is what? Q is your amount of, so here what is the this given? So here it will be, so the amount of substance is directly proportional to the equivalent weight. Okay, so this is your from second law of electrolysis. So what it is states, so the amount of substance, okay, so how much amount of electricity, the same amount of electricity which you have taken, you have passed to the two different electrolytic solution. Okay, so whatever the amount of substance is liberated or deposited at the electrode, so that will be directly proportional to what? It will be directly proportional to the electrolyte equivalent weights. Okay, it will be directly proportional to its equivalent weights. So we have considered the amount of substance is directly proportional to equivalent weight. Now here, suppose now here what we have considered, see here the down solution. Okay, we have taken same current. Okay, current flow is same. You can see the down diagram here, right? You can see. So what is done here? So we have taken uh, same current. So same current is passed. Okay, same current. The current is same. Okay. Now the same current, what we have done, we have passed to the two electrolytic solution. So one contains copper sulfate and another contains AgNO3. Okay. So we'll consider only two. Here they have taken three solutions. Okay, let us consider only two. So so it is like this. So we'll not consider this. So only this. So directly this is connected here. So we have two. So we have two. So first we'll consider this two. Okay. So what? So we have two, because here two electrolytic cells. One is of AgNO3. Okay. One is of copper sulfate. So these two electrodes. Okay. To this two electrolytic cells. Okay. What is done? The current is passed, and the current is same, which is passed to the, because they are connected through the same point. Right. Now what will happen? Whatever the electricity is passed to the electrolytic solution, which is containing the solutions. Okay. What will be the weight? The weight of the silver. So Ag, the weight of the silver and the copper deposited will be, it is given as what? It is given as weight of copper deposited. Okay. How much copper is deposited upon weight of Ag deposited? Weight of Ag deposited will be equal to equivalent weight of copper. Okay, equivalent weight of copper upon equivalent weight of Ag. So how much ever the current, same current you are passing, whatever the amount of substances it is deposited or liberated at the electrode, it will be equal to what? It will be equal to its equivalent weight. So it is given. Now suppose, now here what we have done, yeah, okay, so this was the first condition. Now here we have three cells. Now you can see three cells, right? So the same. So anode, cathode, anode, cathode, anode, cathode. So through the same electric current, okay, so current is flowing in one side, electrons are flowing in one side, right? It is opposite to each other. So what is done? So same amount of electric current is passed to this three electrolytic cell. One is a Ag nitrate. Okay, another is what? Another is copper sulfate. Another is aluminum nitrate. So there are three solutions. So whatever the amount of substance is deposited, so same electricity is passed. So the amount of electricity is same. Okay, so the same electricity is passed. So when the amount of substances starts to deposit or liberate at the respective electrodes, so this will be directly proportional to their equivalent weight. So how it is given? So this what amount of substance, that is weight of the substance of Ag is equal to equivalent weight of Ag upon equivalent weight of copper, okay, which is equal to Z. That is Z is equals to Ag by Z is equals to Cu. Okay, so equivalent electrochemical equivalent is nothing but it is equivalent to your equivalent weight also. So whatever the weight this is there, what is there? Your uh, equivalent is there. Okay, so whatever the amount of substance is, whatever is deposited here, so that is directly proportional to what? It is directly proportional to equivalent weight. So this equivalent weight we got from what? So we got from first, that is amount of substance deposited is directly proportional to what? It is directly proportional to Q. So Q is what? Q is I into T. I is your current in ampere, T is the time in second. So if you remove the proportionality sign, that is Z into IT. So if amount of current that is current passes one 1 ampere and time in 1 second, okay, then W will be equal to Z. So what we have done, so W is equal to Z. So the amount of substance, whatever is deposited from the second point is directly proportional to equivalent weight. So it can be like this also, that W is directly proportional to E is directly proportional to Z. Okay. So amount of substance deposited is directly proportional to the equivalent weight is directly proportional to the Z. Okay. Of corresponding elements of corresponding metals. Okay. So like this. Fine. Is it clear? Is this second law clear? Any doubts? If you have any doubts, you can ask me. Okay. So let us solve one problem on this Faraday's law. So this is the first question. A solution of copper sulfate, okay, is electrolyzed for 10 minutes with current of 1.5 ampere. What is the mass of copper deposited at cathode? So atomic mass of copper is given. So just see how it is solved. Okay, so let us see this. So here So this is a solved one. Okay, so later we will take some unsolved questions. So here, what is done? So we know that. So what is done? The solution of copper sulfate. So what we have, electrolytic solution is there of copper sulfate. This is electrolyzed. Electrolyzed for 10 minutes. Okay, so the time is 10 minutes. Time is 10 minutes. Okay, 10 minutes. Then with a current of 1.5, 1.5. So I is equals to 1.5 ampere. What is the mass? Okay, what is the mass of the copper which is deposited at cathode? So atomic mass of copper is given. Okay, now we know that Q is equals to, what is Q? Q is equals to IT, right? Q is equals to IT. Now, do we have I? Yes, I have I. Now T. T should be represented in seconds, but here it is given in minutes. So how will you calculate T into seconds? So it will be 10 into 60 seconds. Okay. So it will be how much? It will be 600 seconds. So I is 1.5 and I into T. So T is what? 600 seconds. Okay. 600 seconds. So solve this. So 1.5 into 600, how much it will come? Just see. Yes, how much it will come? So it will be 900. So it will be 900 coulomb. So from this you will get the Q. Okay, that is you will get the Q. Now, so that is coulomb charge you have got. Now we know that at cathode, what takes place at cathode? At cathode, your reduction takes place. So reduction means copper plus two electrons will give you copper solid. Okay, so this is the your reduction takes place. Now here, how much Faraday is used? So here 2 moles of current. This is passed, so it is 2 Faraday. Okay. Now, what is the weight of copper? The weight of copper is 63.5. Okay, grams. Now, 2 Faraday means 2 into 96,500 coulombs. So, how much it will be? So, this much amount of coulombs charge is deposited. Okay, it deposits. So, when you pass 2 Faraday of current, so 63.5 grams of copper is deposited. Right. Now, here, so 900. So if I write it like this, so 2 into 96,500 coulomb. So charge deposits 96 point, 63.5 5 grams copper. Then how much? 900 coulombs. So for this much you'll get. So for 900 charge deposits, for if you pass 900 charge, okay, coulomb of charge, so how much it deposits? So like this it is. So what it will be? So it will be 63.5 into 900 cross multiply. So 63 into 9, okay, into 900, 63.5 into 900 divided by 2 into 96,500. So how much you will get? You will get 0. Okay, you will get 0.2961 grams of copper. Okay, like this. So like this is the question. Got it? So standardized, we are taking the standardized equation that for 2 Faraday. So here the moles of current passed is how much? Electrons is 2 Faraday. So for 2 Faraday, it is 2 into 96,500 coulomb charge. It deposits 63.5 grams of copper. So for 900 this coulombs charge, how much it deposits? So it will deposit 0.2961 grams of copper. Okay. One more question we will see on your this. Okay. So solve the first one. How many coulombs are required to deposit 40.5 grams of aluminium when the cathode reaction is Al plus 3 electron giving you Al solid? Okay. So let us solve this. Try to solve. So this is based on your second law of Faraday's. Faraday law. Okay, second Faraday law. Law of electrolysis. Yes. Start to solve. Try to solve. How many coulombs are required? How many coulombs are required to deposit 40.5 grams of aluminium when the cathode reaction is Al plus 3 electrons giving you Al. Yes, who is going to tell the answer? How will you solve this? First step, what is the first step? We know that. What we know? What we know here? So the aluminium, okay, I'll tell you aluminium, the atomic mass is 27 grams. Okay, 27 gram per mole aluminium. Now here W is what? W is equals to Z into Q. Okay, Z into small q, sorry. Z into small q. So W is equals to, so here you can see, wait, I'll write it stepwise. So Al plus 3 electrons will give you Al, right? So 3 electrons are used. So 1 mole of Al is nothing but your 27 grams. Okay. So 27 grams of Alg is deposited by how many electrons? 3F, paradise of electricity. So for 3, that is 3 into F. Okay. So this much electricity when you pass, so that time 27 grams of Al is deposited. Right. But now here, so for 40.5, so for 40.5 grams of Al is deposited by, okay, it is deposited by how much? So it will be again cross multiply how much? Okay. So it will be, so 1 by 27 and 3 into, so 1 mole of Al, that is 27 deposited by 27, 27 deposited by 27 deposited by 3, 40.5, how much? Okay, so it is 3 into 40.5 divided by 27. Do? Yes, understood. Cross multiplication. So for 27 grams, 3. So for 27, 3 Faraday. So for 40.5, how much? So cross multiply. How much you will get? So 3 by 27 into 40.44. Okay, into Faraday. So each Faraday, or first you calculate this and then we'll multiply it by F. So how much you'll get this? 3 by 27 LC 3 by 27 will give you 0 0.111. Okay, into 40.5. So it is 4.5. So 4.5 into 96,500. So this will be how much? It will be 43,425 coulomb. See, 43, 42, 43, 250. Yes. Are you getting the same? So one coulomb is nothing but, so they have asked how many coulombs are required, right? How many coulombs? So it is, yes, this much only. So 46. Understood? Is it clear? Yes, 43, 4250. 43, 4250. Yes. Is it clear? Do you want to solve one more? So solve the second one. Yes, solve the second one. How many coulombs of electricity are required for? How many coulombs of electricity are required for oxidation of 1 mole of H2O2O2, oxidation of 2 mole of FeO2 Fe2O3, reduction of 1 mole of MnO4 minus to Mn2 plus. Yes. So I'll write the first one. Okay. So H2O to O2. So H2O giving you half O2. Okay. Or it will be H2O giving you 2H plus O minus plus 2 electrons. Okay. So your N is what? Number of electrons is 2. Right. It is 2. So half O2 plus 2 electrons only there. So it is 2 electrons are invoked, right? So here 2 moles of so oxidation of 1 mole of H2O. So 2 moles of electricity is passed. So 2 moles of electricity is passed for 1 mole of water. Okay, for 1 mole of water. So it is 2 into 96,500. Okay, so how much it will be? 2 point this it comes to 1.93 into 10 raised to 5 coulombs. Yes, the answer is correct. Okay. Yes, 193,000. Okay. So you can convert it into this. Okay, fine. Next question. Oxidation of 2 moles of FeO to FeO3. Yes. How will you solve this? See here. Oxidation means again there will be loss of electrons. So plus oxidation. Yes, oxidation. So loss of electrons. So your FeO plus half O2 giving you Fe2O3, right? So how this will undergo? It will undergo 2Fe plus 2. So right, 2Fe plus 2 giving you 2Fe plus 3 plus 2 electrons. Okay, so like this you will obtain. So how many moles of this is required? 2F. So 2F, so electricity required is 2F. So 2F, so electricity required to oxidize 2 moles of FeO to FeO3 is 2F. And so electricity required to oxidize is 2 molecules, okay, of FeO to Fe2O3 is how much? 1 Faraday. Okay. So here it will be, so 2 molecules is there. So 2, 2, okay, it will get cancelled and you have 1. So for how much you're getting? 96. Okay. So 96,500. 1 into 95,600. Okay. So it will be 96,200. Okay. Okay, fine. So 2F will give you how much? 2F will give you gives you so 12 moles. So this will give you F moles. So that will be equal to 2 moles equals to So 1F will be equal to 96,500 coulombs. Okay. Last one, reduction of 1 mole of MnO4 minus to Mn plus 2. The reduction of 1 mole of MnO4 minus to Mn plus 2. So I'll write it here. MnO4 minus, okay. So it is reduction. So plus 5 electrons, okay. It gives you Mn plus 2. See here, MnO4 minus x plus 4 into minus 2 equals to minus 1. So x minus 8 equals to 1. So x is equals to plus 7. So plus 7 and it is 2. So how many electrons are lost? 5 electrons. So this is correct. So 5 electrons. So 5 into F. So it is 5 into 96,500. How much it is? 5 into 96,500. So it will be 4.825 into 10 raised to 5 coulombs. Yes. Okay. Is it clear? Okay, fine. So these were some of the problems. So we'll solve some more. Okay, at the end of the. So tomorrow we are going to start with the next subtopic, that is about batteries. Okay, and types of batteries. Okay, so tomorrow we'll do it, because again it will not be completed. So I just took two problems. Okay, so is it clear? Any doubts up to here? Yes. Any doubts? Is it clear? Whatever has been told. Okay. Okay, fine. So if please go through the things whatever have been told, okay, so that it will be helpful for you. Okay, so you won't so whatever I have been telling, so please read it. Okay, just keep on reading, then only you will get whatever the things have been told in the class. Okay, or else again you'll get confused at the last moment. So whatever is there, so that at that time you just go keep on reading. So if you don't understand also, you can come back to me on the next class. Okay, so there you can ask me. Okay, fine. So it's time up. Okay, so I'll end the session. Okay, so tomorrow we'll meet. Okay, so tomorrow I'll be continuing with the practice. Okay, so thank you. Thank you, students. Yes.